Hello everyone, I'm honored to be here to report on these results of our competition. I'm the reporter Wu Huihai. The members of our group are Dongliang Liu, Yingfeng, Huihai, and Zhou Ruiye. We are all students from the Shanghai University of Electric Power. The topic I want to report today is PI decoder structure, designed for precise iris segmentation and location. I hope my report can bring you some gains in the limited time. Now, let me briefly summarize the results submitted in this competition. We proposed a decoder structure to solve the problem of precise iris segmentation and location, which we called PI decoder. We use units as our basic model structure, taking account of the unique spatial characteristics between the iris, the outer circle of the iris, and the pupil. We designed the PI decoder into a form of multi-branch, which is similar to multitask learning rather than multi-label. Experiments show that such a decoder structure can effectively solve the problem of precise iris segmentation and location. Now, there are actually two tasks for this competition. One is iris segmentation, and the other is eye positioning. In our method, we treat human eye position as a segmentation task. At the end of a network, we output the segmentation map of the iris, the outer circle of the iris, the pupil at the same time, and then through simple post-processing, the boundary is separated from the binary mask image of the outer circle of the iris and the pupil, so that the segmentation is achieved. The effect of simultaneous position. On the right is the result image we achieved. The pink purple part is the iris segmentation result, and the two circles are the position results. Next, let's show our other results graphs. This is the result of segmentation and positioning from the African database. The second picture is the segmentation and position results with server squint, and the third picture is the front view results. You can see that the segmentation and positioning results are almost perfect. Our network has achieved satisfactory results in squinting and the front view. Next, I want to show you what have we tried during this competition. The first is the network structure. We tried UNet and UNet++. When the decoding part of the two structures were modified to PI decoder, both achieved good results. Finally, for speed and efficiency, we choose the simpler unit. Next is the backbone. We can show we choose the MobileNet V2 VGG13 and the EfficientNet V2. Eventually, we choose the EfficientNet V2. In the end, we chose the best EfficientNet V2, and the third one is the choice of loss function. In addition to the conventional BCE and this loss, we also tried a weighted loss function, and we also tried to redesign one using the relationship between the three tasks. Loss function, but unfortunately it did not succeed. Finally, we chose these laws, and the first part is the date enhancement part. We translate, rotate, random size, brightness, and add noise to the training image. In addition, considering there are many pictures with glasses and screens in the test set, we also use algorithms to fork the pictures, simulating the fork on the glasses lens, and perspective transformation processing. Simulated the offset of the camera to simulate the effect of the dimension caused by the screens of the eyes. The fifth part is the decoder structure. We have tried multi in the form of label. 3 segmentation results graphs are directly output at the end of the network, but this method was abandoned in the course of our experiment. We chose a multi-branch form similar to multitask learning to decode the future map. The sixth part, which we think is more important, is to find the relationship between the 3 tasks. We always believe that the 3 segmentation tasks of the outer circle of the iris and the pupil should promote each other rather than accumulate each other, increasing the burden of the network. So we try to find the characteristics between them from space. We also find some simple connections between them. This is an iris acquisition image, and the one on the right is the segmentation image of the outer circle of the iris. In fact, through observation and simple thinking, it can be found that the iris segmentation map is cumulatively included in the iris outer circle segmentation map, because the iris outer circle is a circumscribed circle of the iris. Look at the next one, the purple. The white part of the middle of the iris segmentation image. Yes, purple is essentially not the same thing as the iris. Their segmentation diagrams must have no intersection, but they have a strict containment relationship. Therefore, we can know that the outer circle of the iris contains the iris, and the purple is sandwiched in the iris. There is a unique spatial connection of these 3 tasks. Okay. Using the unique spatial connection, we designed the network into a multi-branch form and called it PI decoder. After the input image passes through the backbone, in the decoding process, it is separated from the branch corresponding to the other circle of the iris, used to divide the branches of the iris, and then separates the purple branches from the iris branches. In this way, the decoder is designed, and the 3 branches respectively output the segmentation map of the 3 tasks. The specific implementation details of the network will not be explained in detail. As shown in the table on the screen, the PI decoder we designed has achieved satisfactory results. The PI decoder has good performance and robustness. It also allowed us to get the 2nd place in this competition. The above is all the content of this report. Thank you all for listening, and thank the organizer again for organizing such a wonderful competition for us. Thank you. If you have any questions about the report, please use the email on the screen to contact us. I also hope you can have more discussions with us. Thank you.